All right, all right. Welcome to IT Security Labs, and thank you very much for joining me tonight. Today we have a slightly different live stream where we will be doing some red teaming work, and we're playing with this very interesting Microsoft vulnerability that was found in 2021. It's the MSHTML, and the goal here is for us to go and learn about the vulnerability, how to execute it, and also try to test our defenses. This is really good for us to practice and know exactly how the traffic looks on the network, and that's really my goal here. What kind of noise is generated when people are running vulnerabilities like this one from 2021? And what can we learn as defenders about the behavior and the best ways to detect? So that's our main goal today. We'll be investigating this vulnerability here. I have the CV number for it here. It's a huge one, but just a summary here. This is just a report that where an attacker can actually use remote code execution in this tool in Microsoft. It affects Microsoft Windows, and Microsoft did update Windows, so you can apply the latest versions of Windows, and this will not actually work as well. But right now, what I found out is that we also have our intrusion detection system, Security Onion. We are sending events from Windows, event logs as well. And I'm hoping that we should be able to detect all this traffic here. As you can see, it's already being detected by Suricata here in our alerts. So that's our main goal. This shouldn't take a long time for us, but this is some interesting red teaming stuff, and I'm excited to look at the events here to see what that looks like. So if you haven't, please spend some time reading about that vulnerability. I'll be switching my screens to show you how that works on the Windows side as well, so you can see what maybe a customer might be looking at, and then we will be able to get it going. So without wasting a lot of time, let me go to Kali. Let's go to my machines. Sudo. Come on. In here, I already have that machine directory. Let me find, what did I name it? Okay, MSH. All right. All right. So with this vulnerability here, the one thing that you need to do is go and get the proof of concept exploit. I'm going to explain what we'll be doing with the proof of concept so that it's easier for us to understand how the vulnerability works. And then we'll actually run it. We'll generate a malicious Word document. Then we have to deliver that malicious Word document to our customer. And once we deliver that Word document to our customer or client, we have them executed. And then we'll observe the behavior here in a second. All right. So there are several repositories that you find from GitHub for the exploit. This one is the original one. I'll tell you right now, it works sometimes, sometimes it doesn't. So I have a backup for us if it doesn't work. But the idea here is with this exploit code that is here, we're going to actually generate a malicious DLL file delivered to the customer in the form of a Word document. And that's what most of this is going to be doing for us here. We actually support DLL for the payload. And when we deliver this Word document to the customer, the Word document, the moment it's opened, if it has the editing features, the Word document itself will actually reach out back to us for a malicious DLL file. Then once it does that, it should actually just run. If you want, I was actually playing with this by manually before this stream started because I really wanted to run it by hand, but I couldn't. Next time, maybe. If you really want to know, like, okay, what is it doing? At first, if you have a malicious cab file that is generated, you can point from within that file what you want Windows to do with this exploit. In this case, this is just the calc.exe example that they're talking about here. But if we wanted to, which is what I was trying to do earlier, we can just come in here, modify this to maybe add a user on the system, or run setutil to bring a payload and run another command to execute it, or niching or something like that. That's, to be honest, that's a fun way to do this exploit compared to the one that I'm going to show you. But I couldn't get it to work the way I wanted it to. So instead, we're going to go with the main repo here. So they will tell you, before anything else, you need to install LCAB on your system. So I'll just copy that. Make sure that you install it. You're going to need a Windows 10 or Windows Server victim, of course. And in this case, I already have that one installed. Then next, just run git clone and clone the repo. And hit enter. So once you clone the repo, you should have it here. All right. Inside of the repo, you will not have something like print1.exe. This was me playing with different types of payloads earlier. But you will have exploit.py and the test data here. So if we ls test, this is the calc.dll that you'll be using as an example that will pop up the calculator. We are really not interested in popping up a calculator today. We want to get a reverse shell. So we would have to generate our own custom DLL file, which is, I think the proof of concept only shows us to use testcalc.dll. What I'm going to do is, let's use MS of Venom to generate our own DLL file. Once we generate our own DLL file, we'll get it to the victim using the same exact method. So the easiest way to do this, let's see. I'll just show you right here because I already did it multiple times. I didn't want to type this whole thing here. All right, let's generate one using MS of Venom. And I'm pretty sure our IP address changed. So let me split this here. My IP address is 3886. So let's put that. All right, so we can use MS of Venom. In this case, do I want the 64-bit? I don't want that one. I want the regular one without 64-bit. With Metapredator, this one. It works better. So this is doc.dll. I'm going to use the popular port 444 because it's easier for us to see and search for it. Try to use ports that are already open on the host, like ports that are allowed already, so it's easier. Like 445 is just a port that will not generate a lot of like noise. It looks like normal traffic. All right, so I'm going to use MS of Venom to generate a DLL file. This should initiate a reverse shell for us. And since we're dealing with MS of Venom up there, might as well use MSF console down here to catch that shell. So as soon as it starts, we'll be doing that. So far we haven't done anything on the host. We just looked at the payload and says, okay, instead of their calculator, we want our own. That's the only decision that we've made so far. MS Venom will probably take a little bit. Yeah, there we go. I did not encode or do anything, but it said here selected the 32-bit architecture. That's interesting. I don't like that. But let's run it and see what happens. If it doesn't, then 64-bit will be our best friend. All right, so the first one is done. Next, let's run this. So this is how we're going to generate our Word document that we need to submit to our customer. In this case, my server IP is 192.168.38.86. And I'm not using calc.dll. I'm using my doc, which is actually just right here. All right. So this word.cab, this is the one that we will actually use later when we deliver the Word document to the victim. We'll pay attention to this one here. But we did get a document already in out. And it's this document.docs. So we need to deliver this to our victim and make sure that they actually download it. So I'm going to do a couple of things here. I'm going to switch the screen to our victim machine so I can show you how we deliver it in this lab for now. Then, of course, in the real world, this is what you send maybe via phishing campaign or something like that to entice the person to click on it. But in our case, we're just going to switch this screen here. And this is our victim, 192.168.38.86. I hosted Python server here on port 80. Okay, so my document is called, it's in the out folder here, document.docs. Let's download that. If your user uses Google Chrome, what ends up happening is Google Chrome will try to remove this. This malicious file actually was detected several times by Google Chrome. So that's what I was fighting with earlier. So I learned something. Google Chrome does a good job, especially if it sees Word documents that look funny, like this one. So that was a good learning experience for me. All right, so before I open the document, let's go back and set up our Metasploit so that we can actually just listen for the connection. So I'll switch the screen again. Right at the bottom here, we need to say use exploit multi-handler. Okay. Then for our payload, the payload has to match what we generated this one with, the DLL with, which is the Windows Metapredator. Is it use? Actually, I have it here. I'm not using 64. Okay, let's use the one that we had earlier, just the regular one. I want to make sure that I can put it correctly here. I don't want to make mistakes. Give me 1 second. I think it was this one. So let's set the payload to be the Windows Metapredator reverse TCP. I always misspell these payloads and they don't work when I do that. Okay, then show options. Give me options here. Okay, my port is already set on 444. So I just need to set up my listener, my L host. to 192.168.38.86. You can use your interface here, like if you knew the interface like ETH0 or whatever, but in this case, I'm just going to set up with my IP address. All right, first, I'm happy with my Metapredator shell. It's set. And here we are all set. So now we just have to wait. Say run. With this, we just wait for the victim to reach out back to us. In this case, let's do it ourselves. Let's see. So here's our victim. They found the file. This is document number 2. When they open the file, this is what happens. So if you've never seen people using exploits within like as macros or in Word documents like this one is complaining that the permissions are not correct. But if you saw the other screen, it probably reached out anyway. Okay, let me switch to the other screen here. Because we have to run this one to stage it. It has to be in here. Okay, I think I know why. I think it's here. That's why. All right, now we're staging it. It's asking me to sign into a Microsoft account. I hope I don't have to. Let's accept. Just give me 1 second. Let me sign into a Microsoft account. I have a trial Microsoft Word. And it won't edit macros without that. All right. Two-factor authentication. I just can't show you this test account here. For some of you spam me. Okay. Okay, so once we are listening, according to our instructions here, when we click on the Word document, we should expect this to happen, where it will reach out to our machine, and then we'll end up with, if you get requests for the Word.html and also the Word.cab file, and when we deliver this Word.cab file here, that's when our malicious DLL is going to be executed, and we should get a reverse shell out of that. All right, so with that, let's go and switch the screen. To the victim again. Let's open Microsoft Word. And if this happens here, a way to get around that is you can just right click and edit. This will automatically try to open the document. And in this case, our document doesn't have much. You just see this little preview here. But if I go back to my other screen here, we should see stuff would have happened right here. So just like what we saw here, things happened, but my reverse TCP didn't work. Let me try it again. One. you might have to execute this a couple of times, but okay, there we go. So this is just me using a different one just to trigger it, but this is what it should work as, where you deliver your payloads. My cab file actually didn't show up here as well, but it should. If you do this the very first time, I probably need to clean my cache. But once it works, you get a reverse shell. And the biggest learning point for us is not only is the process of generating this payload and seeing how everything works, was I was using PowerShell Empire to do something similar to this, and you get to learn a very, very valuable skill to see how all these big APT groups are doing. And this exploit that I'm showing you here has been used by some really big nation state actors just to get reverse shell on systems like this. So if I type shell here, you'll notice that I'm already on the system as a user Vagrant. And I can CD to C there. Let's go to the users. How many users do we have? We see administrator here. We see all the other users here. Who am I? All right. So once this happens, we can now start asking ourselves, okay, we know the exploit works. Sometimes it doesn't. Can we go to Security Onion to see if anything actually ran? And here's an interesting one that I triggered earlier in the alerts. Hi, BT, how's it going? So just like last week when we did something similar to this with Windows, this one I generated earlier, you will notice right away that this one here was caught by Strucker. So there is a Yara rule, but the interesting part is it actually catches it by the name. I think it calls it by name. Yep, right here. So if it catches it by name like this is just suricata as the files were moving across the network. There are ways attackers can bypass these things, like if the files were encoded, for example, or I'm not sure if it even Strucker will be able to extract the document from a zipped file or other ways of hiding that attackers might use. But right now, with the way that I sent the file, we actually saw this. We should be able to get a pickup of this and extract the original file, just like what we always do. I might not do that today, but we should be able to just request a pickup for that. So that's the first thing, is at least one thing fired. In this case, it was Strucker. We can go and do some hunting ourselves. In this case, I was looking for DLL files because I was like, okay, I'm trying to understand. I have Windows events that are coming here. I have Strucker actually has 4. What else did Strucker see? All right, while that is loading, I still have a Splunk instance. Let's see if it saw anything in the last 60 seconds. I don't trust this instance at all. It's using the trial license, and sometimes I think I ran out of space. Let me check to see if I even have space. Yeah, I probably ran out of space. Like, not storage space on my system, but the license thing, I'm dumping a bunch of data in there and it's not working. All right, so if I searched earlier for Office using Windows event logs, just to see that document that we were looking at. And if we scroll down here, yeah, there's too much Office stuff. All these probably include when I was installing Microsoft Office, like this one. Let's see. No, no. This is an interesting one. Okay, so this is a process creation. It was created by Explorer, and this is when we clicked on the document number 2. So I've seen other people when they do detection, they'll track these processes and create very intelligent rules that says, for example, if they know, in this case, this CVE, it runs a process called DLL32.exe. So they will track, okay, if you see DLL32.exe running from this path here, where is that path? It will be running from this path here in C user profile update at temp. So if you see that process spin up, and it started after a Word document was launched, and it was running a custom DLL file, chances are it's this exploit. So the rules can be created that way. And really, that's why I do things like what I'm doing right now, is to try to understand those relationships. And once I get very comfortable with all this, the next thing is, okay, how are these rules created properly, and which tools are out there, or at least be able to just read other people's rules. And we get way better by doing so. Okay. Other indicators are files like this one. Let's see if we saw that file. Okay, so here's tracker. Tracker shows. So did tracker see this file? I don't think so. Okay, what about everybody? This file might be the one that gets extracted while on the host, and I was hoping Windows event logs or Sysmon would have seen it, but so far, no luck. Okay, let's look for the process that actually starts this. I think it's Win. It's defined somewhere in here. Let me find it. It's a DLL32 process. I think I know. I found it somewhere. Let me see. Okay. The logs actually don't tell us, but the process that starts this is called DLL32. I think. Let me search for that. Now it's bothering me. Let me see. Someone mentioned it right here in the issues. And they mentioned it right here. Run DLL32. Let's search for that process, just in case it was flagged by Sysmon or Windows events. I want to see every time that process ran. Can I identify interesting instances? I hope it doesn't. It's not one of those very common Windows processes that does all kinds of crazy things. In this case, it looks like it is. But let's just look for the interesting ones. So that process did two things here. These were two different machines, but it's the same idea. Run DLL32 reached out to this Kali Linux area on port 80. What was that process doing, and how did that we end up here? Let's go find out. Okay, so in this case, run DLL32 was executing print.exe. This is where the money is at, guys. Why is run DLL32 executing print on my system? This was me when I was experimenting with the executable files to see if I can actually run just exe files. And it reached out and we downloaded this file here. So Strucker probably saw this executable file being downloaded. Let's look for another one. This time, what did this do? That's interesting. So here's a hashed exe file again. So it caught all the ones that I was trying with executables instead of the DLL. I'm not sure why this was the behavior, but Zik did extract a file here for us. So that's the next one. So we should be able to track down these executable files again using Strucker, or just pivoting to pcap cases here and be able to get the actual files that we ran with that. So what I learned here is if you use executable files, they're louder than when I was just using a regular DLL file, because everything so far that I'm seeing are all executable files. All right, let's get a pcap for this one as well. So let's say pcap. All right, next. What about the Word document, the Word documents that we had? How many did we have? Let's search for them with the .docs extension here. How many of those Word documents did we send? All right, I see our IP addresses here. There's one that we sent with this IP address, so we can click on that one. We should see our document file being moved across the network. Oh, you mean the doc.dal? Yeah, this one is just going to show us all the Microsoft documents that we had. I don't think that's exciting, but it confirms how many times this was done. So you probably run this command if you're trying to track a file with the file name to see if the same file was delivered, say, to many people. So you'll be trying to figure out the scope of this attack. Oh, this is interesting. Remember where it came from, the out directory when we launched it last time. So this was the GET request that we did with the document file. But it shows us here is the document.docs, and it was document1.docs and document2.docs. So we had a doc.dll. This one was delivered as part of the payload. So I'm not sure if it will actually show like that. Okay, I did see some DLL files. So let's find out what's in these ones. Let's filter by this IP. So we can actually just get to the actual files. So far, we have two pickups that are waiting for us. They just probably just contain the information. It's really nothing interesting there. Like this one. They tell us the ports that were involved. Remember, we hosted it on port 80, so we're able to see this. Let's open it in Wireshark. We should see like a get for something. All right, and then let's go here. All right, so this is our source, and this is our victim. And this filter was for DLL files. Okay, so this was print1.dll. That's interesting. This one says, oh, no. Yeah, this is from Google Chrome. I can tell from the user agent here. It was a get from Google Chrome when I was messing with the DLL file. Okay. I opened our pickup here. So we should be able to see, this was for print.exe. We should be able to see others as well. In this case, yeah, this won't help us much. It's just the file that we downloaded. Let me check for the port. How many times did we see? To be equals to that. 16 times. Oh, that's interesting. I guess these were attempts other than, I'm not sure how that happened 16 times. Interesting. Let's pick on this one. It's just a corn event. But at least we know that port was used 16 times in my environment. But that's kind of interesting. Let's see who can give us. Sysmon might be our best bet because Zik is too loud. What did Sysmon do? I don't think we have looked at Sysmon showing reverse shell ports. Okay, so this was from MetaPreta earlier. So this was the MetaPreta exe that ran a while ago. So Sysmon would tell us who did it, which is kind of nice. And this one ran as anti-authority. That's interesting. Okay, so we do see that the ports do show up when a reverse shell was done using an executable. For example, in Windows, it will show up here. I was hoping to see the one from the DLL file, because that's relevant to our current setup, but that's not going to work. Jeez, that was a lot of traffic. Okay, one more thing to look for. According to our exploit here, and like I showed you when I was running it, we should have these. Word.html request and word.cab. Struck, I didn't see it. That's unfortunate. However, looks like we got some hits here for HTTP traffic. To this destination? No, the destination should be 190. So let's find out how many times did we see that Word document? Because I'm curious. And if we were smart enough, we can do things like group by and get better results to see if how many hosts were involved in this. Okay, while that is happening, let me check the other pcap. It's this one. This time, let me just look at it from here. What happened here? Okay, this looks like an executable file as well. Wait a second. This one is the Word document. This one contains the Word document. Let's open it up. And while it's coming up, geez, we have a lot of these Word.html instances. Okay, so Zeke did see that file, the Word.html. So if a user is lazy and they actually go and just pick this exploit here and run it out of the box, what this shows us is that as defenders, we can just go and create rules that just look for these things here, like what are the odds that somebody will be running something called Word.html on your network? It's like ridiculous. So you can generate a rule here that will detect through that. And really, that's what I'm trying to get to today is let's get comfortable not only running these public exploits, but let's get in the habit of saying, okay, what about this thing? In this case, I'm throwing all kinds of what about. Word.cab should be there as well. But we already see that, especially this Word.html shows up many times as well. And that should be part of detection for us. And with that, let's open Wireshark. So with Wireshark here, we see that we have a GET request from our victim. This is probably from them clicking on the browser, according to this HTTP user agent here. So this document is called what? document.doc. A lot of attackers will just take that proof of concept, don't even bother to change the name document.docs. You can have a rule that says if somebody is really transferring a file called document.docs in plain text via HTTP, and I also see those word.html, I might be looking at interesting traffic here. In this case, we saw that. Then what did we get here? I don't know what this is. Oh, it's just showing us that the server was Python simple HTTP. Yeah, but this was that's interesting. I have no idea what this stuff is. But if we wanted the original document for our own investigations, we can get this one right here by just doing the file export HTTP objects. And actually, there it is. That's one of them. Can do it for this one. That's the one that I wanted. Export HTTP objects. So this one, that's the correct one, actually. Or did I highlight the wrong pickup again? You know what? All right, so you can export these objects here and also just get a good idea of when did the transaction happen, which machines were involved in the discussion, and how did the traffic go, who initiated it, and things like that, which is good. Oh yeah. So this is the one that I wanted. If you want a nicer view, of course, the contents are just going to be a bunch of gibberish. The interesting thing is we need to figure out if Straka breaks down exactly what prompted that alert that we saw earlier, because that's kind of interesting. So we can save all that's the document. I just will not save it right now, but that's the document there. Before we go, I'd like to go and figure out what Straka found. Why was Straka complaining from the alert? And I think that was the that was the pickup that I was just looking at. Let's try to understand this alert here. I'm going to pull the rule that generated this alert so we can try to see what they are talking about. We should have a link somewhere. So this was written by Jeremy Brown. Rule reference is a Twitter account. I hope it's well documented. By the way, follow me on Twitter as well. I post all the time. Okay, like we said earlier, it's a Yara rule. Okay, so this is the Yara. Okay, so if you haven't read Yara rules before, they are not that hard to read. If you know regex, you'll be in a better place. But this is a rule for our CVE, as you can see. And the conditions, the strings that we are looking for, that's interesting. So target mode is equals to external. This must be part of what's put in the metadata. Then we have a attached template. So our Word document reaches back to us. So this URL is saying, hey, if you see in this part here, we must have something like object or something. This says that there is something within the Word document that's reaching out to external. We also have XML. I think if we go back to our exploit, reproduce.emd, this is gold right here. we are referencing this file here, this document.xml stuff. I think that's what the URL is looking for inside of the doc. All right. Then let's go back to the rule. We said this is looking for the target mode of external. I think when I was doing the macros earlier with PowerShell Empire, you can tell it specific information like whether to close the document, when to execute, and things like that. And I think these are some parameters from the strings in the document as well, where it says target mode external. I wish we had time to go and dig into the actual files. All right, so we found the Yara rule that was created. Kind of interesting stuff here, being able to interact with Yara, really cool stuff. So props to this Jeremy Brown for creating a simple but effective rule that actually catches this. So I'll make sure that you're running something like Straka in your environment to be able to see how these things actually work. And I was hoping our message will show us which parts actually merged. And the rule says weaponized document that exploits 2021 4044. Awesome. So this was kind of different from what we usually do, but I hope you learned something from it. And I'm hoping to actually do real life exploits that actually have been out there before, weaponize them myself, go and observe what these attackers are doing. And like I said earlier, this specific attack that we did today is being used or was being used in 2021 in the wild by nation state actors. I'm pretty sure it's still being used right now. And you do need this type of detection that actually works. So that's what I had for today. If you have any questions, please let me know in the comments. Otherwise, I think this was a good way of observing things. I like this stuff. Thanks, BT. Okay. This is interesting. It says it was document.xml.realms. Okay, so from here, oh, that's the document that's the file that I just downloaded. Next time, I'm hoping to spend some time weaponizing PowerShell Empire to deliver executables and DLL files in Word documents as well. It's something that's very common. And I think it's time we get to know these things. Let me know if you prefer machines that we break into with other exploits other than this. But for now, I think this should be good. And thank you all for joining tonight. Please remember to like and subscribe. Otherwise, I will see you next week. Thank you.